this. Yep, it's on.
Yes, it is.
Welcome everyone to this video. This is the first time I'm doing interview style video on the channel. And today I've got with us Trent Shumay from IoT Design Shop. And we were talking in the shop the other day, and I was getting really curious on his journey, how he went from his starting in computer and game design to where he is now running a successful machine shop. And I wanted to learn more about him and share that with all of you here. Welcome, Trent.
Good to be here. Thanks, Arthur. It's exciting to kind of think about all this and walk through it. We'll see where it goes.
I recorded this back in I think it was June 2021, and I undertook a lot of editing on this. And to be honest with you, I was completely ignorant and naive of the amount of work that it takes to edit a long form interview like that. And it got overwhelming, and I took on other projects that were shorter and simpler and quicker to complete. Not because I didn't love this project, because I really had a hard time messing with the flow of the conversation, because I really enjoyed getting to know Trent. So you're going to see a little bit that has some heavier editing, and then the editing is going to ease up as you progress through this video. And I know if you love geeking out and hearing about people's journeys, if you've ever been in computer sciences or have a computer IT background, and if you wondered what a journey into manufacturing might look like, you don't want to miss this. Let's get him back here now.
I think helpful for everyone here. Like when you started in your working career, did you have manufacturing on your radar at all?
Not really. It was interesting. My journey was kind of that I came out to Vancouver in the first place to go to UBC for computer science. My ultimate goal was to become an architect. So there was an element of sort of the notion of design and the physical world in terms of my plan, but it didn't go there. I ended up getting my computer science degree, and the sort of market was so hot for programmers and stuff like that that it didn't really make sense to keep going. So at that point was when I went into 3D graphics and video games and stuff like that. And so manufacturing never really occurred to me at the time. It was really 3D that I was excited about. And I'm pretty old. That was a long time ago. That was when there was silicon graphics machines and some of these things that could do OpenGL for the first time, and we were excited about like spinning cubes and stuff. So it wasn't, it was pretty early days, but certainly the one kind of I guess the one tendril that was in there though was in high school, our drafting class had probably one of the earliest AutoCAD rigs in existence, and that really captivated me at the time. And so I was like really, really interested in sort of the drafting and the CAD side of things. But I don't think I could have even visualized manufacturing at that point. No.
Yeah, it's interesting you talk about the spinning cube thing. I can remember like my first like Radeon card Banshee, or my first Voodoo Banshee card, and I remember installing it in my PC, and I was like, okay, do the 3D cube thing.
Yeah, totally, right.
And I was like, whoa. I would just sit there and I would just run the test again and again and again.
Absolutely. Like that was a big deal at the time, and like what was actually really impressive to me when I first started was I was right on that cusp too. The 3D graphics boards came out the year I sort of got into that industry. My first games and stuff I worked on were actually on PlayStation 1, and then all of a sudden the PCs started kind of coming to life with the 3D accelerators. And it was such an interesting time because the thing is, people had been doing this in software, and actually the code that was there for like the software rendering stuff was unbelievable, like and optimized and absolute gurus and stuff. But then the hardware kind of came and stood that on its head, right? Where it wasn't really about optimizing for, whatever Intel architecture and stuff. It was like, how fast can I pump vertices and polygons into this, dedicated coprocessor, and then let her fly basically. And so it changed a lot at that time for sure.
Yeah. So I'm curious, you're talking about starting on the PlayStation, are you allowed to share any of the projects you actually had a hand in there?
Oh yeah, for sure. So I mean, my first game was NHL 98 for the PlayStation 1.
Okay.
Actually, I did some work on NHL 97 for the PC as well, but then the first thing that I really got to dig into was the port to the PlayStation 1 that year. So it was pretty cool. I mean, those machines were interesting, and it's actually one of the things about even sort of, you know, not to jump too far ahead, but in terms of like CNCs and robots and G code and all this other stuff, it's actually really interesting because those were sort of the days of simple machines too on the video game side. The consoles and things like that probably didn't have as much power as a modern CNC controller even, right? So we were really kind of programming down at the metal and trying to make these things go fast. And so it was pretty cool.
Yeah. So you start on the PlayStation doing like the NHL and all of that. And I like how you're like linking it to where you are right now and like the similarities you're seeing. So how far did you make it in 3D design? Like what was that cutting point? What was that transition for you where you're like, okay, I'm basically done in this space. I'm moving to manufacturing. Mm-hmm. What did you discover there?
Yeah, so that was interesting. And that was kind of the origins of the IoT design shop. So I had left video games and started a mobile software development company. Again, one of my themes has always been to write small programs, right? And so I worked in games, things got bigger and bigger and bigger, teams got bigger and bigger and bigger, and it was crazy. And then the iPhone came, and I was like, "Whoa, this is kind of like back to basics, right?" All of a sudden I can go write small programs again, right? So that was sort of the idea. And so that was what I did. There's a lot of details there that aren't super relevant, but as we got down the path, we got into hardware and into IoT and Internet of Things stuff. And we did a lot of Bluetooth stuff, sensors, all that kind of jazz. And, but where it sort of went was, it was hard to imagine, say, building a sensor for measuring load, or we did some stuff with automotive and things like that without an enclosure and without a mount and without, a bracket and without, and then, a case, a waterproof case, an IP67 case, all this stuff for these boards and sensors and things that we were building. So we had this other problem, which was that was kind of, to go to somebody for one-offs in that sort of space is prohibitively expensive, or at least it was. I think we're getting better, but you're not going to go hire an industrial designer to make the box for your one-off sensor, right? So so the gateway drug to manufacturing was sort of that need, and then what came next was, then how, and so 3D printing was basically the transition point. So we went from, design 3D, a lot of software stuff, to wanting to build these hardware sensors and devices, to how do we mount them, to, oh, hey, there is this Makerbot thing that seems to be getting some momentum and stuff like that. So we were in the pretty early days of 3D printing at that point. And so we had the old school, Makerbot 2X, all that stuff. And that sort of took me into that space where it was like, hey, all of a sudden, I can grab, at that time I was using Rhino as my modeling package. I can create solids, I can export them, I can 3D print them, and we can kind of do some really interesting things here, right? And we actually took a gamble on a few things in the early days too, and released them in 3D printed enclosures, where we were like, you know what, this is a test unit, or this is, I remember we built a Bluetooth development kit. We're like, this is going to other engineers and developers and stuff. Like, they don't care if it's a glossy white Apple, enclosure, as long as it's functional, it has an on-off switch, and there's and the other thing too is, even for those designs, like, and they're put together with screws, so if they have to take it apart and fix it, it's easy, right? Like, there's that type of thing. So there's actually crossed over. So we had this internal debate where my co-workers were like, dude, you can't release that. It looks like crap. Like it's a 3D printed box. And I was like, well, but what if we just tell the truth? Let's honestly take photos of it, say this is a 3D printed box. Just so people aren't expecting anything else, right? And we started releasing little products and stuff like that, and nobody cared. So then we were like, oh, okay, so that sort of started the process basically, and then it got out of control from there.
Yeah, you started to realize, is what I'm hearing, right? Like you're like, okay, we've got these sensors that we're developing, and the basic softwares and like all the Internet of Things is coming out, and you're like, okay, but we need to put these circuits to where they're going, and now you need some sort of package. But I love how you're sharing, like, yeah, like just be simple, be transparent about it. Yes, this is a basic enclosure, but the important thing, what I'm hearing, it's the sensors and all the software that went with it. And you're like, look, I just want to get this in your hands. Like, it doesn't need to be super polished.
Yeah, exactly. Like we might only ever make 50 of these or 100 of these. Like these are not mass market consumer products. These are things that an engineer is going to use, So yeah, it made a lot of sense.
So can you share a little bit about like what was like one of your first sensors, like that gateway to, okay, I need an enclosure for this because I need this sensor to be in these people's hands?
Yeah, I mean, one of the very first things that we did was we were measuring, we were basically measuring load on suspension on mountain bikes.
Okay.
So it's kind of an interesting problem. Okay, so you've got your shocks, you got your shock travel. How do you know, I mean, other than feel and stuff like that, but how do you know if you've calibrated that correctly for your body weight, for your riding style, for that type of thing? And it's actually kind of hard to measure. Am I using 50% of my travel range, 75%? I mean, you can tell if you're using 100 or 110 because you're hitting the bump stops, right? Then it's too much. But have I tightened it up too much after that, and I'm not actually getting my full range of motion stuff? So it was a good example in terms of a demo product that we did, because we had to come up with, and the solution was relatively simple. It was a Hall effect sensor and a magnet mounted on the forks. But that's a pretty good example of, like, I mean, if I have to go hire a designer or somehow go through a conventional process to build that, it's going to be a pretty expensive demo, and versus if you somehow have the capabilities to build your own, then almost regardless of what it is, it's probably good enough for something like that. And so that was what we did. So the transmitter on it was a simple Bluetooth device that would connect to your phone, because we were still really into the phone thing, and could measure your suspension travel and tell when you bottomed out and stuff like that, which was pretty cool.
Yeah, it's a great way, because I didn't even know that was a possible thing in the industry. I was like, okay, if you hit your hard travel, that's it. Okay, I bottomed out. Back it off a little bit, drive around. Okay, how does it feel? How does it feel? You got different guys driving it. Okay, how does it feel? How does it feel?
Yeah, exactly. Yeah, that's the thing, and for people that are really, really into it, I mean, it's a pretty deep dive if you don't have telemetry or a way to measure it.
And so that's what got you into all of this. So you went from the 3D design in video games to now you said you started with Rhino, which I played with that software for a little bit too, because there was a time when it was free to market.
That's right.
And I was like, okay, free, I can do 3D manipulation for free. Okay, let's play with this. So what was the uptake like, going from creating 3D design graphics for a video game purpose to now you're going to designing 3D products for market?
Yeah, so that was an interesting journey, because a couple things happened in sort of that interim. Like the obvious thing, and it's I want to qualify this by saying I still do a ton of 3D printing today. However, I do find maybe what people obsess over with printing and stuff like that to be a little bit confusing, or I'm just not fully aligned with it, because obviously I'm a member of the Prusa forums and things like that, and there's a lot of obsession over, like, oh, my layer quality, my print quality, oh, there's a couple little voids in my print, how do I fix it, and stuff like that. And we were kind of on that path too, but then we realized that the printer is a great tool for certain things, but if you start to worry about surface finish and quality and mechanical strength and things like that, that you know, you've got a different set of problems to solve. And that was kind of the next big turning point, which was like, okay, so now we do need to make some things that look pretty good and are pretty usable or are mechanically sound. You know, we need to do some aluminum stuff. And again, instead of doing the smart thing and, you know, maybe partnering up with a machine shop or finding somebody who knew how to do this, we were like, let's figure it out, you know, let's head down that path and see what we can figure out. And that was probably, I would say that was, and I mean, people that have a lot more experience in this and stuff than I do are probably laughing already, right? Like, because that was definitely the deepest dive, or the hardest one was like, you know, let's get a CNC machine and see if we can figure this out. And again, the first, and I don't actually know what precipitated this choice, to be honest. The first obvious thing was like, well, let's grab some sort of desktop thing. Like at the time, the Roland, I guess it was MDX 40s, is that the right number? You know, the little desktop guys. That was kind of like the next step up from a 3D printer. You've got a little desktop CNC. It's got a nice little spindle, and you know, it's in a box, and you can't stick your finger in there. It's pretty safe, you know. For people who are not inclined to operate large machinery, you're kind of like, I probably couldn't hurt myself too badly with that thing. I mean, let's let's try that. But I don't know why I didn't go there. For some reason, I was like, nah, I mean, that's a lot of money. Let's see what else is out there. And I ordered a ShopBot router, and that showed up. And that was, it was getting bad. I mean, it definitely took it up a notch. The ShopBot was great, and it was good at a lot of the things that we needed to do, cutting plastics and things like that, which took care of a lot of problems out of the gate. But then, you know, the process, I mean, that's honestly where I admit I had the biggest gap, or that was the hardest thing to figure out, was just this whole going from a 3D printer is a pretty safe thing, and you're not worried about feeds and speeds and materials and, you know, depth of cut and rigidity and fixturing and all this other stuff. And then you just dive into the deep end without really knowing too much about it. And, you know, there was a ton to learn on that thing, but it was a good, it was a really good machine for that. Like, it's pretty forgiving. You can't really wreck anything. I mean, your worst case scenario was really like completely misjudge what you're doing and either knock the part off the table or rip the tool out of the collet. Was sort of the worst of it. And so either of those are recoverable.
They definitely are. I have done both of those things more than once. And they weren't on like a router table. They were in a full-blown, like, you know, $250,000 CNC machine. So, but you're right. There's that difference between, okay, you're doing additive and it's like, okay, I just got to make sure there's media in there and I can print my 3D, versus now, okay, how do I hold the part? What kind of tools do I use? How fast do I make it cut? Like, it opens up this whole other world that was at the time completely alien to you. Completely alien.
Yeah. Like, that was the real, where like the rubber hit the road or the car hit the wall, or I don't know how far to take that descriptor, but you know, it got real, I think, is maybe the best way to describe it. It got real pretty quick, because you're not in some abstract world anymore. There's things, there's 2x4s flying off the table. You know what I mean?
So what was the first thing you cut on your new ShopBot?
It was enclosures, actually. Yeah.
Okay.
We were doing a run of enclosures that needed to look pretty much the part. Now, it's funny, and I mean, you'll appreciate this too, is like, although that seems like a fairly obvious thing to do, or it seemed like an obvious thing to do for me at the time, I completely underestimated like Yeah, I'm dealing with enclosures, which are, basically thin-walled plastics and with a lot of fine features, and the
Yeah.
edges are gonna vibrate and rattle as I try to cut this thing because I don't really know much about cutting thin walls and stuff like that. So it actually was quite a nightmare, but it worked out. We got through it. That was the thing. I mean, the and that was probably early days on the router in general, was like, just make sure to give yourself a lot of time and buy two sets of material because we're going to learn something in the process, right? And then different things would show up. Oh, this thing has threads, or this thing has whatever, and you're like, oh geez, that's a you know and then when I think back to it now, like, these things are all, and these things are canned cycles on a lot of like real CNCs and stuff.
Yeah.
But at the time, when you don't really know anything and you're trying to make these features and stuff, you're like, man, this is a problem we have to solve here. Yeah.
Yeah. Well, and it really, for me, you're always like talking, okay, like you discovered something new, like that's the next problem. You found a way to overcome it. And just really, because you have this vision of whatever it is you're up to making, the enclosures, and you're going to do whatever it takes to actually make that work. Yeah,
Right.
there might be extra material there, you might break a tool, you might have some setbacks, but so you know that, and you're going to buy extra material, you're going to allow for extra time because you understand that there's a lot to overcome.
Yeah.
Like, is that a mindset that's always been there for you? Or is that something that was developed through programming and all of that other journey on the other side?
Yes, yeah, that's what I was gonna say. Is I think that discipline, or that side of it, has just come from the general engineering practice that
Mm.
I had to deal with. Like, towards the tail end of my time in software, we got into a lot of like back end servers, things that were supporting hundreds and thousands of clients and stuff like that. And so this discipline around, like, don't release code on a Friday night sort of thing. It definitely stayed true as I went into the next phase. And then the other issue with the IoT and the electronics thing too is that you have a lot of concerns around sort of like robustness and accuracy, making sure the thing doesn't fail. And, we never
Mhm.
took on anything hyper safety critical, but it's that discipline around, like, the sensor's got to work when it's -80, it's got to work when it's +80, it's got to work, it's got to gracefully recover when it gets disconnected, it's got to deal with its battery running out, like all these things. And so that became part of the practice. Now, is
Mm.
it always perfect? No. And, like, more times than not, if there's a mistake being made or something, it's that 11th hour, oh god, I got to get this thing out, and that's when the error occurs. So I mean, I would not sit here and say that I'm a perfect process guy, but when you can, it's better than not doing it. And especially being aware, like, we've started doing more stuff, especially in automotive and in some places where there are, again, it's not hyper safety critical stuff, but there are potential risks and downfalls and things that can happen. And so that part of it has always just been part of it, sort of proper engineering in my mind. Um,
Mm.
but yeah, I mean, it helped a lot, but it didn't mean that there weren't mishaps, and there weren't times that were pretty frantic.
So you're talking, like, as you're outlining all of the systems, and I mean, doesn't matter how good anyone's system is. If anyone's watching right now and they're like, "Oh yeah, but not my system," your
Yeah.
system's gonna fail. It's not a
Yeah.
question of if, it's when, and are
Yes.
you prepared? And it sounds really, Trent, like you're entering this very prepared. You understand that there's gonna be shortfalls or things overlooked, and I mean, it really sounds like you start these projects and you're like, okay, what are all the variables that are important to be successful, and then ensuring that you test and try and develop the solution to meet all of those demands, being open to testing to discover anything that you might not have thought of ahead of time.
Yeah, that's right. And I think that's sort of the key. That's the key approach here. I mean, I think what's interesting, or what's been different in this stage of of sort of my career, my approach to these things though too, has been that there's things that are in your control, there's things that are out of your control. It's just the reality with how things work. I mean, in the physical world, there's more things. I mean, it's funny. I think people that don't understand computers maybe that well, or aren't software engineers, think computers are crazy and like unpredictable stuff happens and all that stuff. And it does, I agree. But I find the physical world is that for me, where I'm like, yeah, you know, like best laid plans can still go a little bit sideways. And so setting the realistic expectations and then, you know, some mitigation plans. And I mean, the other thing that's really big too is one thing at my shop is it's complete transparency. Like a part comes in or something comes in and I'm not the person to be like, oh yeah, no problem, we'll just do that and whatever and blah, blah, blah. And then I go and don't know how to cut it or can't figure out how to fix it or whatever. Like I see stuff and I just use my gut reaction and I'm like, whoo, you know, like that's not actually a part that's going to be terribly easy for me to manufacture here. But you know, and I turn away maybe not as much work as I take, but I turn away work that I know I'm not going to be successful at. I mean, I had one a job come in RFQ, which was like relatively simple part and design. But you know, it was basically a pretty long turning part, and they want, you know, to progress from aluminum to titanium to whatever other materials and stuff. And I look at a part like that, and I'm like, you know, it's a pretty simple part. I know I could figure this out. I'm not a titanium guy. It's right at the limits of what I can fit in my lathe. This is one of those things where if I really wanted to, I could tackle this and I could figure it out. But the first thing I'm going to tell the customer is that there's shops that are going to do this in their sleep. And this isn't one of those shops. Now, if there's some reason that you really, really want to work with me and you want to go on this journey and figure it out, we could do that. But what you're really looking for here is a relatively mass produced, mass market titanium part, which, you know, if I go down my checklist of things that we do well, it's not on there, right? And so for both of our sake, I want to flag that and be upfront. And you know, the parts that I do the best at are things that require a bit of design input, require a bit of hand tweaking, a bit of hand holding, maybe something that somebody hasn't, you know, fully fleshed out yet, and I can help participate in the creative process and build these things out, and then we machine them and fine tune them and stuff all day long. I have complete confidence in that. Other things, sort of mass production titanium stuff, well, I'm not as confident on that, so I'm upfront.
Well, and that to me, Trent, it makes IoT stand out. Because I'm sure, you know, there's shops out there that would just say, yeah, like that guy that are like, oh yeah, we'll figure it out, and says yes to all the work that comes in the door. And I've definitely worked at and worked with shops like that. And the atmosphere it creates is it's just one that where no one's really having any fun with it.
Yeah.
I mean, but the way you're like, okay, you're like, look, if you really want to work with me and you want my support, and that's cool, we'll make it work. Just understand this is not my strong suit, because it's just such a humble approach to that relationship. And for me, what I'm seeing there is like that possibility in the future. The guy's like, okay, he was really open, transparent, steered me in the right direction. And now I've got this other thing. And, you know, when we were talking about his strong suits, this actually fits perfectly into his strong suits. Or he has a buddy who's looking for a shop who maybe wants a little bit of that hand holding and that expertise that you offer. And they're like, yeah, go see Trent.
Yeah. And it's funny. I'm just thinking about this, Arthur, like it is a leap of faith. That's the one thing that I have, you know, I'll admit I still have a hard time with. It is a leap of faith to have a good customer who's brought you, you know, 10 contracts that you've been able to do a great job on. They bring you that 11th one and you're like, damn, this is going to be a stretch. you know, and I have this choice now in terms of like, I don't want to like lose this relationship where I send them to somebody else and then they go there and they're like, that guy's fine too, you know, whatever. Trent's full of crap, whatever. This guy's fine now, and he's closer to home, so I'll just go there from now on. But I've forced myself to do it because I'm like, you know what? The most important thing is that customer is going to get their parts and they're going to be correct and stuff like that. And if it turns out that they discover other people and stuff, I mean, great, you know, I'm not hyper competitive like that. It's rising tide floats all boats, right? But
yeah,
most of them come back. You send them even off for, you know, like I had one recently who is a really good customer that does a ton of composites and aluminum and stuff with me. Came in looking for like a pretty high production run on duplex stainless, right? And
it's 2205 or 2505?
It was 2205, yeah.
Okay, well, it's not as hard, but that's not that's not on my list of materials I would select.
Yeah, exactly. I looked at it and I'm like, first of all, I mean, the one thing is the customer is they're like in biomedical and stuff, and so their requirements to come in a lot are, you know, fairly exotic. I've worked with I work in PEEK for them a lot, and which is a relatively easy material to work in and a relatively unforgiving one when you wreck PEEK stock, right? Because every time you do that, you're like, oh, there's $300 or $500 or whatever. So it's actually interesting. Like PEEK ends up being a pretty good fit for me because I've done so many different plastics and things with the enclosures and everything else that if it comes down to taking a gamble on a PEEK job, I'll do it all day long because I'm pretty confident that I'm not gonna mess it up or it'll be, you know, relatively minimal. And so a lot of people don't take a chance on that material because they don't like the what happens when you make an error. But PEEK I'll do all day long. Duplex stainless though, I look at that and I'm like, yeah, and especially in a high production, they needed it in a hurry and stuff like that. And it was a good example of where, so I looked at it and I'm like, man, I really want to do this because I don't want them to have to find somebody and the relationship and stuff. But if I mess this up, it's going to be worse, you know, and a real headache. And again, and I know there's shops out there that do duplex stainless all day long and lots of hard materials and things like that. And so, I mean, they're going to have the tooling, they're going to be able to do this, right? So that was the thing. But long story short, the customer just came back with 3 new RFQs for, you know, composites and aluminum stuff. So it's not like, you know, it's not like they wandered off. But it takes a leap of faith to not be like, yeah, I'll figure that out. And then just to try to keep the relationship.
Well, yeah, and like you said, okay, if it was in PEEK, it would have been fine. But it's identifying those materials, and that's not uncommon in manufacturing where you have a shop that specializes in a material group, like the 2205 and the duplex and, you know, like 17.4 pH and all the harder, the nitronic 50s, and they love doing that. But then you ask them to do PEEK, man, nope.
Yeah, no way. I'm not touching it.
Or, you know, like there's G10 and other material groups where they won't touch it. Yeah. They absolutely will not touch it. And it's like, from my side, because I have a variety of background in job shops and all of that. And now I did like 15 years manufacturing side, 5 years now on the distributor side. It's like, I look at it and I'm like, man, like there's tooling solutions for all of it. Like, but it's that confidence. And there's not a lot of shops that I know that would talk about that material so confidently as you are right now. I've had many of the shops come to me and I'm like, okay, this is the tooling, here's the process. And they're like, nope, okay, we're no quoting it.
Yeah. Yeah.
So in the future, I'm just going to send them to you.
Perfect. Yeah. Perfect. Just become the PEEK house. Yeah.
Yeah.
Yeah. It's always such an interesting thing, like the way that works and the way there's a cycle or an ebb and flow to it also, where things will come in and it'll be like all composites for a while, composite, PEEK, ABS, whatever. And then, yeah, I don't know. Then the wind kind of blows the other direction, and it's steel for a while, and then all of a sudden it's aluminum, and then someone shows up and they're like, yeah, I want 70-75, because these parts need to be hard. And so like, it is like that. But then, and then just, yeah, like you say, though, it's almost like finding your bracket in there where you're going to go, because I don't know how many people would like want to go that way. I mean, obviously places do, but yeah. I don't know, it all depends. I guess it all depends. And it depends on how much capacity you have and stuff too. Here it's like, I'm figuring this stuff out, and it's small, so I don't want to stretch too wide. But I mean, if you have lots of specialists and stuff, then that would be a dream actually. But yeah.
Well, and that'd be a different type of shop than where you're at now. So we've come kind of back to your journey. So you started with the shop bot, and then we've gone off on the mindset, which I love how you just keep bringing it back to, it's the customer's experience. They have someone they're making these parts for. Your priority is making sure those people get their parts. It's not about just building your books and filling your books full of hours.
Yeah.
So you went from the shop bot. What was your next piece of equipment?
Yeah, so that was when the Tormach showed up, the Tormach 1100.
Okay.
Which is such an interesting machine, because Tormach has this kind of storied history of, and I've still never really been able to piece it together. And and in full disclosure too, we'll get to it, but I work with Tormach on some beta stuff too, and they're a group who's incredibly humble as well in terms of what they're doing with their machines and all that kind of stuff. And so I got this 1100 Series 3 in, and I mean, it just freaked me out. Holy crap, this thing's cutting through aluminum and steel and everything, like like the shop bot could never dream of. And so it was like, this is the big machine. Now, what was interesting about that was a couple things. I mean, one was that, they've gone so deep on that customer experience. I mean, if you want to talk about customer experience, like they've gone so deep on sort of promoting and making sure people understand how to use this machine from the ground up. And I should back up a bit too, that what precipitated, or what made me pull the trigger on that thing, is we had actually won a contest. So we did an industrial design thing and won this contest with Microsoft, and got sent down to Maker Faire in San Francisco to show off our creation. Okay. And while I was at Maker Faire in San Francisco, we happened to be stationed in the same exhibit hall as the manufacturing folks. And so everybody was there. The 3D printer companies were in there. Shopbot, those guys, but Tormach had a booth, and I went over there, and again, like, you'll laugh because like, you're a real machinist. I'm not from that background, right? And so I went over there, and they were doing a demo where they had I think they were just debuting the 440 at that point, which was like really like a $5,000 desktop mill, though, that would cut aluminum and whatever else, which is like kind of like and that machine has its strengths and weaknesses, but the whole concept that you could have a thing for $5,000 in your garage that you can throw a block of aluminum in and mill is like, there's tools that cost $5,000, like cutting tools, and not CNC machines, right? So it is what it is. But I went there and like went to the booth, and I was watching this, and like, it was just like mind altering, like just mind blown, because there was all these things happening that I was like, and obvious stuff, but like, they pull a block of material out, they put the next block in, and then just start cutting again. I'm like, whoa, how is this machine, like, how does it know where the part is and stuff, right? Because I'm coming from the router world. I'm like, how are you like re-zeroing that and stuff? They're like, well, you don't have to, like, it's accurate, it's calibrated, and then we've touched off, and like, you're like, oh man, you could like do so much with this. You know what I mean? Like, this is like a real machine. So
well, all the blocks start pulling in, because then you're like, oh wait, okay, well, you know how to address stuff in programming and everything else. You're like, oh, okay, so hold on. So then and then all those pieces start.
Yeah, everything just starts falling together. You're like, oh man, this is actually what I needed. Is I need a mill. I need like something with some accuracy and repeatability and stuff like that. And so then that was sort of where that started. I think by the time I got home from that trip, I had already ordered the 1100 and was waiting for the truck to arrive,
Yeah.
So that's sort of the next machine in the journey. And again, what I would say about it was not perfect, not like a dream machine or anything in this, but so serviceable, so easy to understand. So much effort goes into their education program and showing people how it works, and their investments in social media and the YouTube content and all that other kind of stuff makes this a thing that you can kind of pick up and be like, okay, like I get it. I mean, it's still pretty intimidating. Again, like not coming from a machining or manufacturing background.
Yeah.
When you go and you throw a 2x4 hunk of metal into a vise and, kind of hit go on the control, that's a bit of a moment of, oh, geez, what's going to happen, but a good way to graduate, like the approach there was really like 1/4 inch and smaller diameter cutters and, relatively limited feed rates. And if you do make a mistake, that machine will stall really before cutting itself in half or cutting through your vise. It just doesn't have enough torque to destroy itself. You know what I mean? So that's, it sounds bad. And when you're trying to like go fast or whatever, it would be an impediment. When you're learning, actually, there's a certain comfort in like, if I plow this machine into the vise or table, it's just going to stop. Like,
you have a little bit of like that comfort zone around it. You're like, okay, worst case scenario, I'm like replacing a tool. I'm not going to need to replace my machine spindle or my my vise or chuck or whatever else you're holding the material in.
That's the thing.
So I'd like to rewind for a second.
Yeah.
And you first saw the Tormach and everything started piecing together, and now you've learned CNC and all of that. So pulling on from what you learned in programming, is there any like links there that you see? Now I get if you talk about the programming, it may go over my head because we're a little bit opposite. I have a lot of machining history and a very little bit of computer sciences from high school and running an ISP. And then you've got the other side. You're like heavy into the computers, graphic design, all of that like software engineering stuff, and a little bit of the manufacturing so far. Yeah. So what links do you see there in your own experience from like going from that whole software world to a very hardware world now?
Yeah, it was interesting because I mean, certainly, and even going back to the 3D printing thing is, there's this moment where I sort of realized, like, again, I think people think often if you don't understand the process very well or you don't know the machines, you think there's exotic things happening. Like there's those memes that go around, where people say like, they think of CNC machines like a dryer and you like put your clothes in there and it comes out and it's magic, or, you throw a block of wood in and hit go and this bowl comes out. The whole G-code thing was the eye opener, and it was the same as 3D printing. It was the same with the router, and then same with the mill was like just this epiphany of like, oh, like this thing just does exactly what you tell it to do. It's not actually smart. I mean, some of the newer controllers are smarter, obviously, but it's not actually smart. I'm telling it to like, move, cut, feed rate, RPM. It's just following those commands. If it goes in like it bangs into something or it rips the vise off the table or anything, it does not know this. It's like going to go back and it's going to run this code over and over and over again. It's a computer. It's just a computer, right? And at that point, then I'm like, okay, I get it. Like, I get it. There's nothing magical in here. This is just a computer. It's going to run my program. The program is written in G code. and here's what I can do with it. And then, I mean, where it probably was a little more intuitive for me than someone coming at it, not from the programming background, was like, then I go through the instruction set and I look at what commands are available and what how everything works and what I can turn on and off and what the M codes do and everything like that. And, but there's, honestly, even on big machines and stuff, there's really not that big of an instruction set really when it comes to G code and some of the extensions and stuff. It's not really that big a deal. So you get your head wrapped around that pretty quickly. But it's interesting though, like despite having the programming background, I really went the CAM route really quickly. I didn't get into too much like coding at all. It was mostly like, okay, now that I see how this works, it was easy for me to make changes to my post processors and to add in features and things like that I wanted, or to even to understand how they worked. I'm like, what's going on here? Like when this cycle starts, why is it going through this weird sequence of events that seems to be wasting time, and how can I cut those out? You know what I mean? For me, that was intuitive. Where I look in the post processor code and I'm like, oh, that's crazy. Yeah. Oh, I see why they're doing that. That's safe, but it's not necessarily fast. So I know I'm not going to need to rely on the safety aspect of it, so I can take that out, and it is faster, right? So that was probably the big part of the programming. Now I had in sort of computer graphics and everything, where I had gotten to was actually I was a pipeline and engine programmer for most of it. So I was largely concerned with in that case, from Autodesk, 3D Studio Max or Maya. How does the content come out? How do I get it into a game engine? How do I do the thing? And so this was exactly parallel from, in this case, I was using Inventor, but now I'm using Fusion, basically the same, is how does this content come out from Inventor or Fusion into, how do I create the cam paths and everything and like that? And then how does that come out into G code? And it was basically exactly analogous to how I was getting game content out of the packages, right? So that part was pretty intuitive. And then, but the devil's in the details. Obviously, the machining part was the hard part, and figuring all that out.
Yeah, and it's all of that, like you said, like you're breaking down like the translation of the languages. It's like it'd be like if you were, well, like when I started, I was programming in BASIC. And then I was like, okay, well, I really want to learn VBasic. And I was like, so I learned VBasic. And then I was like, okay, well, I want to play with JavaScript. I want to do web design. So it's just literally, like you said, you start looking at the things. So whether it's a CAN cycle, like a G81 or a G82 or a G83 for drilling cycles, right? For your pack, for your dwell, or you're turning and you're looking at your like threading cycles. You're just really learning a new language.
Mm-hmm.
And whether you're telling a computer to display graphics and movements on a screen, or you're telling a CNC control to go shape this piece of metal.
Yeah.
You're really just telling a computer how to draw something.
Yeah, that's right. Yeah. It's the same thing. Yeah. So it's pretty cool. I mean, and it's an interesting part, and like kind of an interesting segue into the journey was what really was the hard part for me was just the materials, the feeds and speeds, and the way some of that stuff was sort of introduced. Like if you don't go deep on understanding sort of the cutting process and what's happening and how the material is being removed and stuff like that, like the first tier was really just kind of getting into a groove of like, I know this works. Or like, here's manufacturer sort of recommended data, and I'm kind of copying those feeds and speeds. But I'm not really understanding what the difference is between, a cutter that has 2 flutes or 3 flutes or 4 flutes, and what material I'm using it on, stuff like that. I'm kind of just going by, what I saw and seemed to work and things like that. But that was where I was getting into trouble. And that was the part where there was no analogy to the software side, really, where you're dealing with that physical. By the time you've got like flutes on a cutter hitting a material, that was the thing I had a really hard time with understanding. The programming and stuff wasn't too bad. It was just that intuition for, how many how many thousandths of an inch is each of these teeth on the cutter removing as they rotate, and what material is this and what should I be doing? Yeah, it was pretty hard. Yeah.
Yeah, there's definitely something there that it's about that science of the shearing of materials and the way they interact with the cutting tool. I had never really thought about that till you shared that, but you're so like there's no corollary from because
No.
on the computer design side, whether it's gaming or whatever, you're literally like, okay, draw this and it draws it. It's not like you've got to figure out, okay, well, actually, that's the most efficient path. You know what I mean? Like, there's no
Mhm.
like the closest thing I would think maybe to it would be just like if you look in some of the programming languages like Python and JavaScript and stuff, where you can have like your different subset structures and notes and all of that in the formatting, where some guys have super clean code, everything's perfectly annotated, all the flows, right? Like a PLC, like all the flows make sense.
Yeah.
Whereas if you have someone who's new to coding, they might be like putting all these different operations and you get that, 1 second lag between button presses. For
Yeah.
an experienced coder, there'd be none of that lag.
That's right. Yeah. Yeah. That's actually a pretty good way to look at it. And in this case, it's that notion of, say, jumping from material to material, where you're just like, okay, this was working fine on, ABS, but now I'm cutting polyethylene and everything's gone to hell. And why did
Yeah.
that happen? You know what I mean? And that was always the trick. And even understanding understanding the cutter geometry, and like, and again, like, it's not like I went deep on it, but when you're coming at it from not knowing anything, the first thing you're going to try is like, okay, so I got this, I don't know, I got a 1/4 inch 2 flute end mill. It seemed to cut wood pretty good. I'm going to throw a piece of plastic in there and see what happens, right? And it melts, and you're like, oh man, this is trouble. And then,
Yeah.
and it gets worse or even more complicated as you go, and again, kind of circling back to like the Tormach thing, is like a Tormach 1100, not a super rigid or forgiving machine. And so you're trying to achieve decent surface finishes and things like that. And you're trying to cut as quick as you can on a machine like that. And just understanding the trade-offs with, your sort of all different, like the multitude of parameters. How do I get this machine to cut as fast as it can is where it definitely doesn't have a great analogy in the programming world.
Yeah, and that was like extra skills where you're like, okay, I don't have any skills here. I need to develop this understanding, this knowledge set. And so you started with the Tormach, and now you've added another machine to the two more sheet machines after that, right?
Yeah, 2 more machines came in after that. So one was, and they came almost at the same time, but one was sort of a target of opportunity, I guess, which was I had been, and I'll cover that one quickly because I'm not as deep into it right now, which is a Tormach lathe came up. And so I had not really done much turning. I had like a little tiny manual lathe that I would use for like cleaning up things, cleaning up bolts, or if I needed to kind of take a couple thousandths off a shaft to make it rotate properly. That was sort of the extent of my turning. But it had been on my mind because, again, of course, one of the jobs that I did for one of the customers who I really appreciated working with and stuff was I need these little stainless steel pins to hold the assembly together. Can you knock those out for me? And I'm like, wow, can I? Maybe I can. That was one that I took a chance on. It wasn't such a big stretch. Like, it was like just shafts. I'm like, I can, worst case scenario, I can turn them by hand and figure it out. And it turned out to be the worst case scenario, though. There's nothing worse than turning 316 stainless by hand on a tiny little micro lathe. It really doesn't, want to deal with that. So that was bad. And then right at that moment, though, this used Tormach lathe popped up just across the border in the US. A guy had literally turned it on and done the tutorial part and never
Yeah.
gotten back to it. And so it had been
Oh.
on his shop floor for 2 years. He needed to move. He was like, I need to get this out of here. So that was good. It was right, of course, right during the peak of COVID. So what should have been a 45-minute trip across the border in a U-Haul to go get this machine ended up being, you know, having to arrange a freight carrier to bring it across the border during, you know, COVID time.
Oh, wow.
But again, thankfully, I at least had the experience of moving a couple of machines around, so we got that figured out, got that in. And so that machine's here today, and it's again, I would say it's very similar things about the 1100 with that is it has its limitations, although for what I'm doing, like for like, I mean, long story short, it belts out those little 316 shafts all day long and doesn't even break a sweat. So I mean,
yeah, which is awesome.
Yeah, that's what I needed. You know what I mean? That problem solved. I'm good here. Yeah. But since then, a lot of things have come up where it has been nice. Where it's like even the way I would think about things, like, you know, I would in the past, I would not hesitate to like throw a round part either in the 4th axis on my machine or in some sort of chuck on my CNC. And like, as long as it doesn't need to be some magically perfectly concentric thing or whatever, I could make it work. But having the turning center sitting there has certainly freed up that thinking, and the speed of the lathe for doing round parts is, you know, again, to any actual machinists and manufacturing people out there, they're like, yeah, duh. But to me, it was like after kind of compromising making round things for a couple of years the best way I could, I mean, this is, yeah, it's perfect. I mean,
well, it's night and day too. Trying to make something round on a mill versus making it round on a lathe is just like you said, it's obvious now, but if someone new to the industry is like, okay, well, what machine do I get? Are you making round parts? Get a lathe.
Yes, exactly. And it's painfully obvious, but when you don't really know that, or you haven't had that experience, like you're like, well, I could probably make it work. And I can probably make it work on my mill, or I can do this, or I can do that. But but really, if you're going to create any substantial number of parts, it's kind of the only way to go. And now the question, of course, is like, you know, again, like we discussed, I don't bid on things that I can't do successfully, but I see enough turning jobs now where I'm like, well, really having something a little bit beefier and a little bit more automated would make a lot of sense. But am I going to be a turning house or not? I don't know. You know, like it's a tough one.
Well, and if you ever want to sit down as you're contemplating that, man, I would like to take that out of this because there's a lot to consider there. Yes. I would be happy to sit with you and go over it because I've seen some shops do it really successfully and other shops not so successfully. It's nothing on that shop that weren't successful there. It's just they kind of tackle it like, okay, well, I'm in it on my own, so I'm going to figure it out. And it's like, man, like a 30-minute call could have completely changed the success level of your implementation.
Yeah.
So much so, a lot of it, when they actually sit down the road, because they find that struggle, they're like, oh man, like I can't get it to work the way I thought. It's like, well, if you would have bought this machine, slight variation, it would have been fine. But now they're stuck with a machine. They either have to try to sell to get the right one or buy a second one, or a lot of other stuff comes up, right?
Yeah, absolutely. And actually that's a really important thing to touch on too, which is, and probably segue into the next machine to a degree too. Like that whole notion of speccing these things out and getting the advice, I think is really critical, especially like I'm finding and not that I'm running big machines here, but as I'm graduating from these machines, like it's one thing to get a little Tormach or something and then decide that you're going to go a different direction. But like you say, you could end up in a really weird place because, and a good example is sort of the segue into the next machine, which is the Haas TM1P that I have, which, so I had kind of mentally committed like, I don't know, a year and a half ago, whenever that was, to like, okay, I need something one step up here in terms of rigidity and just production capacity, automation. I will want a machine that, you know, will be able to cut some slightly larger parts, and you know, that's always the journey too. Anytime you buy something, then inevitably the next order comes in for like, you know, 1 inch longer than your travel or whatever. But
yeah,
that's the way it goes. And so that was running through my head for a long time. And frankly, in the Tormach forums, one of the really common things is anytime somebody complains about rigidity or speed or anything like that, there's a chorus of like, you should have bought a Haas if you're worried about these things, right? And so I had seen that enough times that I was like, okay, well, maybe I should buy a Haas. Not that I was complaining about those things. I always kind of had an intuition for that machine, which is like, anytime I saw those things, most of the time I was like, yeah, you're doing the wrong thing. You're trying to cut, like, you got to take your time here. But anyway, that's a different story. So the Haas thing. So my first approach was probably the obvious thing. I think what most people would do graduating out of that was like, I go to the Haas site, I start looking at things. You know, your choices are pretty straightforward, especially if you're not going super big. Like right away, I see the mini mills, I see the VF series. I start comparing them and understanding, or trying to understand what the differences are and stuff like that. Talk to people online, talk to the sales folks at Tom Skinner. And that was all super educational. But where I ended up getting to, or where I gravitated to organically, despite, you know, and to be fair, in opposition to some of what I was being told, right? Because what I was being told really was like, dude, you know, you're on a bit of a journey here. You're on a path that's where you're gonna want a VF at least, or, you know, something, because any of these little things you're not gonna be too happy with for very long, because it's just going to kind of give you a taste and then you're going to be off to the races, right? So I was like, okay. But then you start doing the pricing and all that stuff. And where I gravitated to was mini mill, right? And I think where I would have gone without sort of any intervention or anything coming up, where I would have gone would have probably been a fully optioned out mini mill, which you know, which is actually it's a very capable machine, but it's actually it's a pretty expensive machine by the time you throw everything on there. If you're gonna like do every bell and whistle and upgrade the cooling pump, and you're gonna put the probe, and you're gonna do all that stuff in there, you know, you can drive the price of that mini mill up pretty quickly. So, and that's what I did, and I drove it up to the point where I forget what it was now, even say 60, 70 grand for a mini mill, which made me pause and say, wow, like I didn't really imagine that this was going to be 70 grand. I think you start on the start page at like 38 or something like that, right?
I think it's just under 40. When you start building.
So I was like, okay, well, and that didn't necessarily put me off, but it was like, I really got to think about this and make sure that I'm doing the right thing. And then anyway, long story short, what happened in the interim though, is that down in California, on the demo list and stuff like that, this TM1 pops up, TM1P. And like, I don't even know what that is, but the price looked good. And again, it was during the pandemic, and Haas was hit a bit of a circuit breaker there, and these things were discounted like 30 and 40%, right? So
the promos last year were just because, and part of it too, I mean, yes, they had inventory, but there was still shops that needed to expand because of the demand being placed on them. They're like, but the shop can't afford to expand. They're like, if we don't do anything, they're not going to expand. And what's the ramification for them if they can't?
Right. That's interesting. Yeah. Cause it was like, there were great deals, and the TM1 was one of them. Now, what was interesting about it though, is because it was a demo machine, it actually took most of that decision-making out of the equation. Cause it's like, here it is, here's the package. It's a pretty basic TM1. It's got very few hours on it. But it's not optioned out or anything like that. But for me, it was like, okay, perfect. I'll make it work. I'll make it work. You know what I mean? For the price, I'll make it work. And so, so the guys helped me get it up here. And so then two things, basically. One is, magic night and day difference, just, you know, and again, people operating bigger machines than that are laughing at me right now. They're like, dude, like, that's like the kids one, right? But for me, it was like night and day difference. All of a sudden, I just got this confidence level where I can push the green button and more or less the part will be there at the end of the cycle, and it'll have a nice surface finish. It'll be accurate, and I'm good to go. Yeah. And so that's a bit of a game changer, because like even with my other machines, with the smaller machines and the, you know, lack of or less rigid and stuff like that, like I was always walking it in. I could hit my tolerances, but I'd be walking it in. I'm like, I got to leave a couple thou, check everything, go dial it back in, adjust it, and I can get this part to, you know, within a thousandth in terms of tolerance, but I'm going to be doing it step by step, walking it in. Okay, there it is. And, you know, as long as nobody breathes on the machine and the temperature doesn't change, I'm good to go. Which is a good learning process, right? But this machine, I started doing the same thing, and every time, like, I'm like, okay, so I've left 2 thou of stock there because I'm gonna walk it in, and I go calibrate, and it's exactly 2 thousandths out, right? And I'm like, oh, this is like, this is some next level stuff, right? So like, and you got to understand, these are limited expectations for me. So I'm like, whoa, so the right number is 0, you know, and basically it cuts the parts as I've programmed it. Wow. So then I can start moving, you know, and then even other things like, you know, little mishap. Oh, it stops, right? Oh, there's an overload on the servo. I stopped. You stopped. Like, this is awesome, right? Not that I use that feature much, or try not to, but then I got a lot more confident though about, like, you know, I can tee up my final job of the day. I've run this program 10 times, hit the green button and walk out, and I'll come back tomorrow and that part will be there. You know what I mean? And if not, I'll get a text message. So that sort of changed things again, right? But my point, like in terms of speccing that machine, is there's definitely a few features I would love to have on it, but I'm not any worse off, or I'm producing the same parts I would have produced on that optioned out mini mill. And I would have spent a lot more money on it. And instead, I think in both cases, I realize I do need to get to another machine here at some point. But I've done it in a fairly cost-effective way, and I think that TM1 is going to be part of my inventory for a long time. But I think the machine that I would add next is going to be different than if I hadn't taken a bit of a baby step there and I had gone. Because if I would have gone deep on a mini mill or something, I would still be worried about kind of paying for that and amortizing that out, right? Versus having spent, you know, much less on the TM. I have that freedom now to think about next year what machine comes in, kind of thing.
Which is awesome. And like you said, it's an investment in an income generating asset in the end. I mean, I work with shops that have 10, 12 machines, and they still have one of the TM1Ps they started with, because they're like, well, it makes good parts, and if it fits in the work envelope, why am I going to put it on a bigger machine? Like, I still have parts that size. It still makes me money.
That's an interesting one, right? And that's something I would be curious on your perspective on, is like, I have 2 schools of thought, right? Which is, I mean, I think on certain parts or certain types of work, your setup overhead and having a table full of parts has huge value to it, and you're minimizing sort of the amount of time lost to tool changes and stuff like that. But then also in a really sort of high turnover, high flexibility shop, it's hard to equal the value of a second spindle or a third spindle or a fourth spindle, you know? So you can be, there's this school of thought where you can be more efficient and certain parts fit that profile. Then there's just the brute force of, like, you know, I could buy a bigger, faster machine, or I could buy 2 more TM1s and have 2 spindles. So I'd be curious what you think and what people do with that.
Well, and I think that's a great point to pause it. We're kind of hitting our time window here,
Yeah,
and I would love to have a second one where we start to look at that side of things.
sure.
Would you
Yeah.
be open to that, or
Yeah,
even
that would
taking it
be,
offline or a
that'd be
video?
great.
I just think it'd be really cool to capture that, because I'm sure there's lots of people that would like to look at that side of.
Yeah, I think that would be a really interesting conversation for sure.
Yeah, and just I'm just so appreciate your time today, Trent, and everything you've shared, like how you've taken all that mindset you developed in the world of programming and game design, and like where you were directing the pipelines to get, okay, here's the model. Okay, we need to get it into the software. We need to get it displayed on the console or the PC, and everything you learned there to developing your sensors. And okay, well, I got these great sensors, but how do I actually get people to use the sensors, and to where you are now with all the machines you have. And it's just a crazy journey, man. And so grateful for this, because like we have that common origin in computers. I jumped ship from computers at a different time than you in your journey. Um, but just that shared history. And I know so many people in like the software and the computer world that they don't see any other place to bring their troubleshooting, to bring their mindset, to bring their creativity. And they may not even know, much like yourself or myself at one time, until I walked into my first machine shop, I had no idea. Like that manufacturing could be a place where you can just get so lit up and so in love with what you're up to. Because man, this whole time you've been lit up through this conversation. Like
Yeah.
you are excited to share this with the world, and just to have a life where you've got a way to earn money and provide for you and your family in a way that has you so excited and lit up, man. Like it's a beautiful thing.
Yeah, I'm very fortunate, and I don't take that for granted, because yeah, it's tough, right? A lot of people don't find the thing that gets them excited, but I've been really lucky with this one to find something that's a great fit and fairly natural, and
Yeah.
exciting. Yeah.
Awesome. Well, thank you so much, Trent. If for people that are watching here, we'll put links down below with how to get in touch with you if they are looking for manufacturing solutions or
Sure.
anything else, or if they want to reach out. Is there anything you'd like to share with everyone before we end the recording today?
No, I mean, I think you've touched on a few of the key things. Like to me, it's like, just be humble, be honest, and see if you can find your way through these problems, right? And do it without being afraid. I mean, if there's anything I regret about the journey, it's probably the questions not asked, or the times where I felt like, oh geez, I don't want to bother this person with this question, or this is going to sound pretty stupid. But now that I've embraced that sounding kind of stupid, and just admitting that I don't know what I don't know, the rest of it's gotten a lot easier to navigate for sure.
Well, and that's just a great piece of advice to share. And to anyone watching, I'm open to questions and conversations. It sounds like, Trent, you're also open to start that conversation and to see where it leads for them. And you guys at least know you've got two people right here on your screen. And I mean, if you've made it this far, chances are you're enjoying the conversation. Awesome. Thanks, everyone.